Good morning, students. I am your Nagini ma'am. Today I am going to discuss about the coordination number, how to find in BCC structure. Okay, students, in the last class I discussed you coordination. What is the coordination number? How to find the coordination number in SC, simple cubic structure. I discussed Nama. So in this section I am going to discuss about the BCC structure, students. How to find the coordination number in BCC structure. Okay. Now see, students, BCC. First I am taking the simple cubic unit cell. Simple cubic unit cell. Here I am taking the value, students. So in the last class already I discussed here all corner values, face centers values, body diagonal value, contributions, everything I discussed, Nama. Now see, students, this value is 1 by 8, this value 1 by 4, this is 1 by 2, this value is 1, again 1 by 4, 1 by 2, here 1 by 4, this value 1 by 2, clear. And this face center value 1 by 2, and this face center value 1 by 2. Next, this face center value 1, and this face center value also 1, this body centered value 1. Contributions, clear, students. This values how came in the last class already. I discussed your students with one example. Please once go through that. Okay, now I don't want to discuss again these values, students, and I'm going to the our topic, coordination number, how to find in BCC structure. Okay, students, right. Now I'm taking again one cubic unit cell. I'm taking, students. Okay, now this is the considered particle, students. To this considered particle, okay, it is in touch with this particle, this corner particle, and it is in touch with second corner, and this is the third corner particles. And next, here I am taking this is BCC kada, up to body centered particle you have to take. So this particle also it is nearest to this one, and corner particle also nearest to the considered particle, and one face diagonal particle, students. This particle also it is nearest to the considered particle, but which is the first nearest I don't know. So that means to the considered particles, which particles are very nearest? Corner particles are second, or body centered particle or face centered particle, which is the nearest we don't know, students. So first we have to calculate the nearest neighboring distance. Are you following? Nearest neighboring distance. So first corner particle, face diagonal particle, body centered particle, three particles I am taking. See, students, first corners I am taking. This is corners. Next one, face diagonal particle. Next, body centered particle. Okay, body centered particle, clear. So in these three particles, which is the nearest to the considered particle, I don't know, students. So first I am going to calculate the distance. Okay, now so that means from the considered particle to this particle, how much distance? This is edge length is a kada, so this is edge length a, this is a. So and next, this is the face diagonal kada. In the last class I discussed you how to calculate the face diagonal. Okay, now so this value is how much, students? Face diagonal root 2a. This is body centered, up to the body centered particle you are taking line. Okay, in the last class we took a complete body diagonal value. Last class we calculated root 3a. Now this is body centered particle kada, up to the centered particle. So that's why you have to take the half value of the body diagonal particle. What is the distance from the corner to this corner particle? That is the body diagonal length. So how much? Root 3 into a. So here you have to take half. So that means root 3 into a by 2. Clear? That value you have to take. Now see, students, corner to corner, edge length is how much, students? Distance a. Face diagonal. So this is the face diagonal particle. This distance is root 2a. And from here to here, this distance is body centered particle, root 3 by 2a. Okay. Root 3a by 2. Half distance you have to take. Now this is value is 1a. This is 1.4a. This value is 0. Root 3 means 1.7 kada, root me 1.7a by 2. So that means you will get 0.8 you will get, correct? 0.8a you will get, Clear this one? 0.88. Now which is the smallest value, students? Here 1a, 1.4a, 0.8. This is the first nearest. This is the smallest value kada. So this value, that means body centered particle is very closer to the body center particle is very closer to the considered corner particle. Clear this one? So it is the first nearest, and the second value is corner particle 1a. Okay, so this corner particle is second nearest particle to the considered corner particle, and the third particle is face diagonal particle. It is the third nearest one. So first nearest, which is the first nearest particle? Body centered particle. Clear this one? So right here 0.88, this is the first nearest. Clear? Second nearest corner particles based on the distance, based on the value, students. 0.8, this is the smallest value. Next second value, small value is 1, and next third value is 1.48. This is the first nearest, this is the second nearest, and this one is and this one third nearest. Clear? Third nearest. Okay, first nearest, second nearest, third nearest. So first of all, I'm going to calculate first nearest coordination number. So we have to find how many body centered particles are nearest. Okay, now very nearest to the considered corner particle. So that coordination number we have to find. What is the coordination number? Total number of nearest neighboring atoms. So nearest neighboring atoms are body center particles. So these particles are, how many body centered particles are very nearest to the considered corner particle, students, that we are going to calculate. So first I am calculating the coordination number. Okay, coordination number for first nearest. Okay, for first nearest we are going to calculate. Okay, coordination number for first nearest. Now again I am taking the simple cube, students. Okay, nearest. See, students, now I'm going to calculate the coordination number for first nearest, students. I'm taking the cube here. This is the considered particle. This is the considered particle, students. Okay, now to this considered particle, how many, this is the first nearest, we are going to calculate coordination number. That means how many nearest neighboring atoms to the considered particle, how many are there, that we are going to calculate. That is the coordination number. Okay, so body centered particle is the first nearest. That means it is very closer to the considered particle. So first we are going to calculate coordination number for first nearest. Now see, students, in the cubic unit cell, only one body center particle will be there. Okay, now only one body center particle will be there. Clear? So what is its body center contribution, students? Body center contribution is how much? 1 kada. So that value I am taking. Now see how to find the value, coordination number. So coordination number is equal to how many corners, students? Total 8 corners particles will be there in the cubic unit cell, and it is in touch with how many particles? It is closer to the only one body center particle, and its contribution is 1. So value is how much, students? Coordination number is equal to 8. This is the for first nearest, students. Now I'm going to calculate the second nearest. Okay, coordination number for second nearest I am going to calculate. Coordination number for second nearest. Okay, second nearest I am going to calculate. Now see, students, I am taking again cube. Second nearest arrow. Who is the second nearest, students? Corners kada. So this is the considered particle, students. This is the considered particle. Second nearest is corner particle. So this is corner. It is in touch with this corner, and it is in touch with this corner particle, and it is in touch with this corner particle. Clear this one? So 3 corner particles are in touch with the considered particle, students. So that's why. Okay, 1 2 3. So how to find the coordination number, students? How to find it? Coordination number for the second nearest. So coordination number is equal to total 8 corners are there, and each corner atom, total 8 corners, each corner atom is in touch with how many corner particles, students? 1 2 3 kada. So 3, and each corner particle contribution is how much, students? This one, this one, this one. Values are 1 by 4, 1 by 4, 1 by 4. Clear? 1 by 4, 1 by 4, 1 by 4. So that values contribution is 1 by 4. Then you will get to the 4 2s are 8, 2 3s are 6. That means second nearest, how many are there, students? Corner particle 6 atoms are very very nearest. Okay, Nama. Which atoms? These are corner particles. These corner particles are very nearest to the considered particles. Okay, so this is the second nearest. Now I'm going to calculate the third nearest, students. See here, third nearest. Coordination number for third nearest. I'm taking the cubic unit cell, students. See, this is the considered particle. Okay, which is the third nearest, students? Third nearest is face diagonal particle. So to this face, one face diagonal particle, and to this face here, one face diagonal particle, and one more, this is the third face. This face diagonal particle is this one. Okay, this particle, students. Okay, total three diagonal particles are the three face diagonal particles, and their contributions how much, students? Face diagonal particle 1 by 2 kada. This is 1 by 2, and this one also 1 by 2, this one also 1 by 2. So values, right, students? This is 1 by 2. Now how to find the coordination number? Coordination number is equal to total 8 corners, and next face diagonal particles 1 2 3. It is in touch with 3 face diagonal particles. Only 3 face diagonal particles are very closer to this one, and next each face diagonal particle contribution is how much, students? 1 by 2. So 4 times, then 4 threes are 12, students. So this is the coordination number in BCC structure, students. Clear this one? So this is first nearest body. First nearest one is body center, students. Second nearest is corners. Third nearest is face diagonals. This is about the coordination number in BCC structure, students. Okay, clear this topic, students? Are you understanding, students, this one? Okay, thank you, students. I hope you like this video. Please like, share, comment, and subscribe my channel, students. Thank you.